Hello class, this is a video tutorial on recurrence relations. A recurrence relation is a type of formula where the result of the calculation is inputted back into the same formula and the calculation repeats. It is critical to understand how recurrence relations work and how they are notated, especially in relation to annuities. So let's take a look at what a recurrence relation might be as shown here. So here's the notation that you might see as a question, and here's how we interpret it. You'll see that it's R0, and mind you, R can be any letter. It might be P0, A0, etc. But for the sake of this, I'm saying it's R for recurrence. So the repetition or recurrence of 0 is equal to 4. Wherever you see that R0, that is the number that we have to begin at. Now, this next portion here, it says R of n plus 1. That is saying the next number. So if we are on Rn, that's the current number. R of n plus 1, that is the next number. So the next number, Rn plus 1, is equal to, is calculated by doubling the current number, so 2 times Rn, and then we subtract 3. Now, I could talk a lot about this some more, but I'll just demonstrate to you now what this calculation would look like. So currently, we are at R0. So 2 times R0 minus 3. That will get us n plus 1. Well, if this is currently n plus 1 gives us R1. But R0 is equal to 4. So we can remove this and just put in the number 4. We can calculate in our head. 2 times 4 is 8. 8 minus 3 gives us 5. And that is the first repetition of this recurrence relation. R2, that is the next number after this. Well, to find R2, we repeat 2 times R1, R1 will go here, minus 3. Now here's what we mean, where we take the result of a calculation and we put it back into the same calculation. So this becomes 2 times 5 minus 3. 10 minus 3, that gives us 7. And I hope you can see why this is called a recurrence relation, because it's recurring over and over again. 2 times R2 minus 3. And to find this one, we take the result of the previous and we input it into the same formula. So there'll be 2 times 7 minus 3. 14 take away 3 is 11. We go up to R4 just for this demonstration. 2 times R3 minus 3. And remember, we take the result of the previous and we put it back into the exact same formula. So this becomes 11. 2 times 11 is 22. 22 minus 3 gives us 19. Well, since this question says find R4, we can say that R4 is equal to 19. And obviously this can repeat as many times as needed. But for this demonstration, we're stopping at R4. Okay, so give you a moment. Here is another example. You can pause and give this a go yourself. And I've written again the interpretation of this. So it says start at 100. And now this time, notice how it's not the next number, but the current number is calculated by multiplying the previous number now. So look at the slight difference that you see. N plus 1 is the next number, and we need n. So that's the current number. But this time, it may look like it's notated differently, but it means the exact same thing. To find the current number, we need the previous. Compared to this, to find the next number, we need the current number. Regardless, it is the exact same idea. So we are currently at R0. The next repetition we're finding is R1. R1 is found by 1.1 times, well, since this is R1, n minus 1 will give us R0 minus 15. This one's going to need a calculator. It's a little bit more tricky. But now notice how this R0 is the 100. So we can substitute that into our formula here. And now we can do the calculation. 1.1 times 100, we need to do that first, minus 15. And that gives us 95. So that is R1. We want to go as high as R4. So let's go again. R2 is 1.1 times the result of the previous number goes back into the exact same formula. 95 minus 15. So the 100 can be replaced with 95. That gives us 89.5. R3 is 1.1 times, and here's where the recurrence relation is really evident. We take the result of the previous, input it into the same formula, there we go. This gives us 83.45, and to stop at this demonstration, R4. 1.1 times the results of the previous. I'm just going to copy paste that. And then we minus 15. 83.45. Let's see, hopefully it registers. Oops. Come on. Oh, just going to write that again. 1.1 times 83.45 minus 15. This gives us 76.795. So for this demonstration, we can now say that R4, the fourth repetition of this recurrence relation, is equal to 76.795. So I hope that has given you an insight into recurrence relations. In the next videos, we'll see just more examples of this. And in a further video, we'll look at a shortcut in how to do this in a calculator for a large number of repetitions, because as you can see, it takes quite a while to be able to calculate this. All right, hope to see you then, where we take these next 3 examples. Hope to see you then, and best of luck.